All right, happy day. Here we go. We got 3.12 today. We're talking about factoring quadratic expressions. We're going to do it a little bit differently than you probably have seen it in the past. Okay, when we get to it later on in the section. But since we are factoring, I mean, you guys have been doing factoring since you were freshmen, in some way, shape, or form. Okay, so we got this. I think we can handle this. What we're looking to do here, all right, I'm going to explain it differently than you might have seen it in the past. Okay, so we're going to talk a lot about this box method that we've used in the past. Okay, if you remember from first semester, we did something like this number one, our explore, during first semester. All right. It talks all about this. The following box shows how to multiply x plus 4 times x plus 5. And the area of the box is equal to the non-factored form. Why is that the area of the box? Because area is length times width. Length times width. If I multiply x plus 5 times x plus 4, I get the non-factored form of x squared plus 9x plus 20. And this is our factored form. So today we're trying to go from the non-factored form to the factored form. Okay? We use the box method before to multiply polynomials, and now we're going to use it for the reverse process of factoring polynomials. All right. So if I want to use the box method to factor x squared plus 10x plus 21, what I'm going to do is I'm going to look for two things. I'm going to look for the GCF in the first row. There it is in the first row. Okay. Then the second row. Then I'm looking for GCF in the first column and the second column. All right. So if I look in this first row, I have x squared and 3x, my greatest common factor. Well, we did all that GCF stuff yesterday. If I look with 7x and 21, the greatest common factor is 7. I go vertically now. All right, column number 1, x squared and 7x. I have x, 3x, and 21. So, write the area of the box as a sum of, or as a sum and as a product. Well, the product would be x plus 3, x plus 7. Sum would be x squared plus 10x plus, which we already got from here. That is the sum. That's our non-factored form right here. This is the factored form. So what are we going to talk about today? We're talking about, can you factor a quadratic expression using the box as well as a guess and check method? Do you know how to determine if a trinomial is prime? And can we combine factoring techniques to factor an expression completely? By factoring techniques, I mean what we did yesterday. Can we bring in the GCF? All right, can we bring in a GCF? All right. It gives you this whole, remember, talking about FOILing. Okay, FOIL is an acronym for the 4 products involved when you multiply the first, outer, inner, or last. So consider these products. They can be found using the box or FOIL method. This shows the FOIL method. Notice when we multiply binomials of the form x plus a number, x plus a number, where the numbers are positive, we get something like this. This is all a bunch of words. You can read it, pause it, read it. Okay. I want to talk about this. So what I want to do here, all right, is my goal right now is to find a pair of numbers in this third column. I want to find a pair of numbers whose product, remember product means multiplication and sum means addition. So 2 numbers that multiply to 30 and add to 11. I'm going to give you the first 2. 5 and 6. Both of those numbers will multiply together. They multiply to 30. If I add them, their sum is 11. Conversely, I'm going to show you the next 2, and then I'm going to ask you to do the rest. The next 2, well, I have a product of 30 whose sum is now negative 11, so that means it's negative 5. And this little symbol here means and. This not plus. You can write the word out if you want. All right, so what I want you to do now is pause it and try to fill these out. I hope you actually paused it there. Product of 44 and sum of negative 15. I got negative 11 and 4. This one, negative. So now you'll notice that the products were all positive, double positive, or double negative. So now that my products are all negative, that means one number will be positive and one number will be negative. This one I got -9 and +7. For this one I got -3 and +8. And for this one I got 3 and -8. Okay. So what they want us to do is it says use the pattern. X squared plus a sum of numbers plus the product numbers equals x plus number plus x plus number to factor the expression. So that, that doesn't really help us at all. All right. I don't know. All these words, that doesn't really help us. Okay, they're just saying, hey, factor this expression. So I want to figure out, okay, what two numbers are going to multiply to 12? I'll write this out. I go multiply 12 and add factors of 12. Sometimes it helps people. 1 times 12, 2 times 6, 3 times 4. Holy buckets, there's my two factors. 4 plus 3. What they're really talking about now that I'm realizing is this positive, positive, negative, negative, positive, negative pattern. Okay. Notice here we have a positive number at the end. Our C term is positive, and this term is negative, our B term. Okay. So that tells me if this is positive, then I'm going to need a double negative. I'm going to need two negative numbers. Because when I multiply these two numbers, whatever they may be, they must multiply to positive 20. So I have 1 and 20 and 2 and, I'm going to stop there, 2 and 10. 2 and 10. Well, if both these are negative, I will get the positive 20 that I want. All right, let's keep going. Let's try C and D. Here we go. So C, I want a -8 now, but a positive 2. So that tells me if my final number is -8, then one of these numbers must be positive, negative. So it is 2 and 4. If I want a positive 2, then this 2 must be negative to get x minus 2. How could I check my work? I could FOIL this out and combine my like terms just to make sure. I think the book asks us to do that. I'm not going to do that. Numbers that multiply 35. Now, you don't have to write this 35, this 8 down. Like, some of us can do that part in our head. Some of us, it's hard to, so it's helpful. So I'm going to continue to write it because I know there are those of us that need to see it, okay? So I have a -2 and a -35. So if this final number is negative, remember, one of these needs to be negative and one of these needs to be positive. If I want a -2, that means I'm going to have to, the bigger number is going to have to be negative. Remember, if your middle term is negative and the last term is negative, the bigger number must be negative. All right, now the book goes on this long explanation. In each part 3, you're able to find two numbers that multiply their product and add to the necessary sum. All right. The quadratic expressions for which is not possible, however, For example, x squared plus 6x plus 7, there are no numbers that will multiply to 7 and add to 6. Okay, in this case, since there's not a greatest common factor, we consider that prime. All right, we'll talk about how to solve those types of problems in our next section. We want to unfoil. Then it talks about unfoiling and foiling this expression. To unfoil, we can use the guess and check method, okay, which we're going to do in a second here. But it gives you these shortcuts here. If I have a constant term of a quadratic expression is positive, the constant term is this last number here. It's a constant. It doesn't have any x attached to it. It does not have a variable attached to it. If both signs are positive, both positive if the middle term is positive. Talking about our factors. Both are positive if this term is positive. Both are negative if this term is negative. If I have a negative constant term, then I need one positive, one negative. Knowing that, it really wants us to guess and check this problem. So for example, if I have 3x squared minus 16x plus 5, this last term is positive, but the middle term is negative, that tells me right away that I have two negative numbers that are going to be in here. Now it's on us to figure out which two. Okay, so it says begin by checking to see if there's a GCF. There isn't. GCF is 1, so we have to go the unfoiling approach. The first two terms must multiply 3x squared, making the middle term. Excuse me. Wow, that was a deep yawn. Okay, hope I didn't get any of it too. Next, we need to add the numbers and multiply. We need numbers that multiply to 5, but make negative 16. All right, the only two numbers that multiply to 5 are 5 and 1. All right, and since our 16 is negative, they both need to be negative. So the book does the guess and check method. All right, if I have 3x minus 5 and x minus 1, I unfortunately get the negative 8. If I do 3x minus 1 and x minus 5, I get negative 16, which is what I want. So that's our answer. Okay, so we're going to go guess and check. All right, I have 4x squared plus 5x plus 1. So I have 4x, and I have x. Now the question remains like, hey, how come it's not 2 and 2? Well, I'm going to try the 4x and x first, and then if it doesn't work, then I'll go 2 and 2. What do I mean by 2x and 2x? All right, so I need two numbers that are going to multiply to 1. Well, guess what? There's only one's a prime number, so our life was so easy there. And this is actually factored. Like, this is it. Nothing else we can do. All right. If I were to FOIL this out, I will get my original. Okay. Let's try this one. 2 is a prime number, so that helps us a lot. Remember, prime means that their only factors are 1 and itself. So that means I have 2x and x. I know that I need to get to negative 6, add to positive 1. So what I'm going to try to do here is find a combination that does that. Well, let's say I know that negative 6, I'm going to have 3 and 2. And 2. Holy second. So let's say if I go 2 and 3, then I went, I don't know, minus plus. If I did 2x times positive 3x, or times positive 3, I would get 6x. And if I multiplied the negative 2 times x, I get minus 2x, which gives me 4x. Well, that's not what I want. Okay, I want positive 1. So I got to try again. So this is wrong. All right, so I have to try again. All right, let's try this. 2x minus 3, and then x plus 2. Negative 3x plus 4x. Oh, look at that. That gives me 1x, which is what we want. That means this is our answer, and it's factored. Wow. Now, guess and check takes a lot of time, so we're going to talk about a method where you don't need to guess and check. All right. Let's see what we put down here. Guess and check can be fast approach. So now let's reverse this process. So it talks about, I want you to look at the top of the book there. It says consider the product using the box method of 3x plus 2 and x plus 5. Start on the outside and work in. Factoring says start on the inside and work out from the box. Okay, so let's reverse the process and factor this expression. How do we do that using a box? Okay, the dimensions are going to be 2 rows by 2 columns. The squared term is always going to be right in this upper left-hand column, and the constant term is always going to be in the bottom right. Okay, the x term, so that's 17x, is not going to be in the box. Instead, we need two numbers whose sum is 17. So I want two numbers that add to 17. We need to understand how to find the 15 and the 2. The constant terms, so what they're saying is, if I multiply these two numbers here, I get 30. If I multiply these two numbers here, I get 30 as well. In order for this to work, this must be true. Okay? this 15 and the 2 must multiply to 30 and add to that 17. So what I'm trying to do is find two numbers that multiply to 30. How do I know it's 30? I do 3 times 10. Okay. And then I want two numbers that multiply to this and add to our middle term. And I'll show you that in an example. Okay. Notice that we're then from there, we're just taking the greatest common factor. Let's look at an example here. So use the box method. So I know that I have 5x squared and 12. Well, I want to look right here. 5 times 12 is 60, right? So I need two numbers here whose product is also going to be 60, all right? And they must add to 23. Well, the only thing that adds to 23 and multiplies to 60, well, let's check ourselves. 1 times 60, 2 times 30, 3 times 20. Oh, ding, ding, ding. 3 and 20. So I have 3x and 20x. So again, writing out the factors, especially when we're doing this part, is very helpful. Very, very helpful. I can see that 3 times 20, that is 60. Okay. So now I want to find the GCF. I want to find the GCF of this row. I have 5x squared and 20x. My greatest common factor is at least an x and a 5. I have 3x and 12. My GCF is 3. If I look vertically, 5x squared and 3x, x. And if I look vertically again, 20x and 12, I get 4. So my answer, 5x plus 3, x plus 4. All right, so it gives you this great explanation on how it works using the box method. Awesome stuff. We're going to stop here and we're going to pick up as a class and do a couple more examples. Do it live. All right.